The ambitions to settle somewhere out there go right to the core of our existence.
Compelling reasons to colonize space are to see if we can expand the range of our activities beyond the Earth, or are we really confined to the Earth? I think that's an important question we need to know the answer to. The second one is, what's the role of life? We have on this Earth a phenomenon called life. Is it destined to spread beyond the Earth? We are the species that can cause that spread.
Carl Sagan, the great noted astronomer, once said that we should be a two-planet species. That is, we should colonize one planet and also have the Earth because, for example, the Earth is in the middle of a cosmic shooting gallery. There are comets and meteors whizzing all over the place on a scale of hundreds to thousands and millions of years. And we need a spare planet because it's simply too precious to put all life on simply one planet.
In the vastness of space, there's one destination above all others that stands out as prime real estate for colonization.
Mars is the grand prize of the solar system. It's the closest planet which human beings can settle. It's the closest planet that has all the resources needed for life and civilization.
Mars, the fourth planet from the Sun. It's about half the size of Earth, and at its closest pass is roughly 35 million miles away. The ancient Romans associated its red color with hostility and named it after their god of war. But far from hostile, Mars has the potential to be the most hospitable planet after the Earth. The gaseous outer planets offer no solid ground. Among the inner planets, Mercury is too scorchingly close to the Sun. And Venus, though similar to Earth in size, is baked to 870 degrees Fahrenheit by a runaway greenhouse effect. It also has an atmospheric pressure that would crush any would-be human settlers. Mars does have its own pitfalls. It actually has extremely low atmospheric pressure, which would cause your blood to boil and then freeze. But a pressurized spacesuit can overcome that danger. And while it's cold on Mars, with typical daytime temperatures 20 to 40 degrees below zero, humans could easily survive wearing proper protection. Most important, the red planet, with its carbon dioxide-rich atmosphere, seems to have the natural resources we would need to keep a colony running.
On Mars, we have carbon dioxide from which we can extract oxygen and make fuels from it. There's water vapor in the atmosphere and also in the polar caps. The soil on Mars, the regolith, has the minerals and various compounds we need in order to set up a colony on Mars.
Today, Mars is a frozen desert. But photos taken by space probes show clear evidence of erosion. This means that not only did Mars at one time have water on its surface, but also that it may have once supported life. Finding evidence of previous life, even microscopic organisms, might make the difference between whether we establish a short-term base or a more permanent colony there. Long-range mission planning is already underway at NASA. The space agency plans to return man to the moon by 2020 as a stepping stone to a Mars mission.
One of the major themes for the lunar exploration is called Forward to Mars. And within that theme, we'll be constantly thinking about how we will operate on Mars. The astronauts will be involved with studying how humans react to the planetary environment, how hard they can work, how much sleep they need, how much entertainment they need, how they will relate to mission control. We need to learn to deal with all of these issues that come with people living in far-reaching environments.
An important step in preparing for a long wilderness trip is testing the gear. Setting up everything in a local spot, even in your backyard. Make sure you've got everything you need and it all works. In that same way, setting up a base on the moon is a practice run for setting up a base on Mars. We learn what to do, we learn all the equipment we need and how it works. We get everything working just right.
Everything includes versatile robotic machines like Athlete, which stands for All-Terrain Hex-Limbed Extraterrestrial Explorer.
Athlete is designed to carry cargo on the Moon or Mars. The most important cargo we could carry would be a habitat. That's usually the largest single piece of any human mission.
But Athlete can do much more than just haul cargo. Each side of the machine is equipped with high-definition cameras that give a 360-degree view of the surroundings and display it to an operator based either on the planet, in an orbiting spacecraft, or back on Earth. And each limb is like its own self-deploying Swiss Army knife.
One of the things it can do is take one of its limbs and grab a tool out of a tool holster and use that tool to excavate. So we have built scoops and drills and grippers and other tools. One of the most interesting things is that if a leg were to fail on Athlete, the two adjacent legs could in fact grab tools and disconnect the one leg that's failed and amputate it and leave it on the surface.
With equipment like Athlete, astronauts will be able to establish a long-term base on the Moon and test how self-sufficient they can be. Only then, according to NASA, will we really know if we're ready to go to Mars.
The real acid test of our understanding how to live in space will be to take a crew of, say, 6 people, put them on the far side of the Moon where they cannot see the Earth and have the psychological disadvantage of not being able to connect to the Earth, and see if they can exist for a year on their own with the systems that we designed for them. If we're able to actually do that kind of a test and experiment, then I think we will have checked the box that, yes, we're ready to move out into the solar system and settle more difficult regimes such as the planet Mars.
The Moon's close proximity to Earth, about 240,000 miles, only a 3-day trip, makes it a convenient proving ground. But its environment is vastly different from Mars.
Mars compares to the Moon as North America compared to Greenland in the previous age of human exploration. I mean, Greenland was closer to Europe. Europeans got there first, but ultimately it was too poor an environment for a new branch of human civilization to really develop in. Same with the Moon. The Moon is closer to the Earth. We got there first, but as a place for settlement, Mars is a much better place to go.
Mars has more water and other useful natural resources than the Moon. It also has an Earth-like day-night cycle that lasts only about 40 minutes longer than ours. That's why the Mars Society, an organization of scientists, researchers, and NASA personnel, thinks we should skip the Moon entirely and head directly for a rendezvous with the Red Planet.
Mars Direct is a plan for sending humans to Mars without the need for futuristic science fiction spacecrafts and without the need for a lunar base.
The Mars Direct mission plan proposes 2 launches. The first sends an Earth Return Vehicle, or ERV, to Mars.
Land this on Mars, and then you run a pump and you suck in the Martian air, which is mostly carbon dioxide. And we react that carbon dioxide with a little bit of hydrogen that we brought with us from Earth to produce a large supply of methane and oxygen rocket propellant. So now we got a fully fueled up Earth return vehicle sitting, waiting for us on the surface of Mars.
The second launch sends a crew habitat module to Mars. After conducting their mission on the Red Planet, the astronauts board the ERV to return home and leave behind the habitat module.
Each time we do this, we add another HAB module to the base. And after a few missions, we've built the beginning of the first human settlement on a new world. There is nothing in this that is beyond our technology. It's simply a question of having a little bit of moxie, a little bit of will.
But to skeptics, the Mars Direct mission plan is a non-starter.
If we tried to go to Mars directly, the first step would be something like 20 years of preparation and testing, and at that point, the public will get very bored with the idea of going to Mars. We believe that we can get to the moon in a time frame where the public will be heavily engaged in human exploration of space, and that will enable us to get to Mars in some sense faster because we'll have more confidence and we'll have less risk to human life.
Getting to Mars, whether by direct mission or only after further lunar exploration, is just the first step towards colonizing the planet. But getting there will be as challenging as living there. Surviving the journey will be the ultimate test of human endurance. The trip to Mars is 6 months long. That's when the Earth and Mars are at their closest alignment, making it the best time to depart.
Earth and Mars both go around the sun, but they go around at different rates. And every 2 years, Earth and Mars are on the same side of the sun, and so then that's when it's close. And then it only takes 6 months to get there. When Earth and Mars are on opposite sides of the sun, forget it. You're not going from one planet to another. Not with the technologies we've got. You got to wait for warp drive or something like that.
There are new hardware elements that need to be developed to enable a human flight mission to Mars, but no new technology. Everything we need to make, we know how to make. We are much closer today to being able to send humans to Mars than we were being able to send men to the moon in 1961 when Kennedy started the moon program. And we were there 8 years later.
0, all engine running.
The new hardware will include the Ares, the next generation rocket that will launch man to the moon and beyond. The Ares should be ready for liftoff within a decade. It's about the size of the Saturn V of Apollo fame. Taller than a 36-story building, the Saturn V was the largest and most powerful rocket ever launched, capable of delivering a 53-ton payload into lunar orbit. But the Ares, using boosters derived from the space shuttle, will be able to muscle an extra 22 tons of cargo on each trip to the moon.
So if you have very large rockets, you can have fewer launches in order to assemble the spacecraft that goes to Mars. So the large rocket is really a product of the desire to ultimately look at Mars in our exploration scenarios.
New hardware will also include Orion, the crew vehicle. It will be more than 2.5 times the volume of an Apollo capsule. On its missions to the moon, Orion will dock with a lunar lander sent into space on a separate launch. Unlike Apollo spacecraft, Orion will orbit the moon unmanned, while lunar explorations take place. The astronauts will redock with Orion for the return to Earth. This new crew vehicle will borrow much of its hardware from the space station.
And this is a place where a few tourists come, so basically...
In 1997, retired astronaut Jerry Linenger spent about 5 months, nearly the length of time it would take to get to Mars, aboard the Russian space station Mir. While on the long mission, he overcame many dangers, including the most severe fire ever on an orbiting spacecraft. A chemical leak ignited a blaze that lasted 90 seconds, threatening the crew.
I processed a lot of the things that I think pretty much saved our lives are these oxygen breathing devices, and during the fire, of course, that had to go on quickly.
If anybody knows firsthand how the hardware, including life support systems, will work on the spacecraft taking man to Mars, it's him.
Down here on Earth, you take so much for granted. You know, we're out here, sunshine, the fresh air all around you. You know, in space, you have to make it. You've got to make the oxygen. Up there, you're in a closed ecosystem. You have to recycle, you know, whatever you can.
And the toilet itself is over this way, and it's a very simple design.
For example, we take the urine, collect it using a little funnel, little suction device.
For the male or female urination is this tube here is used.
We'd collect that up, we'd convert the urine into water, water to oxygen, and we would breathe our urine inside that closed ecosystem of a space station.
Of life. I hope you've got a feel for the space station as we flew you through it.
New hardware will also provide power from clean, reliable sources. We're going green to the red planet. Solar panels will do the job on the return to the moon. But the longer journey to Mars will require another power source.
As we get off to Mars, the solar insolation, the intensity of sunlight at Mars, is only about half that at the Earth. So solar panels are less effective. We may have to think carefully about using nuclear power sources in some of these spacecraft. And in fact, people are thinking seriously about nuclear power sources on the surface of the moon in order to generate long-term power and not have to worry about the periods of darkness on the moon where you don't have sunlight and you have to bring batteries up to store power.
But despite all the new hardware, the journey to Mars will still have its share of potential hazards. Just like any trek to an unfamiliar place.
Imagine you're on a wilderness camping trip. You leave home, the familiar surroundings that you're used to. You go out on a long trip, potential dangers, hazards, rock slides, avalanches, getting lost, equipment breakdown, all sorts of possible problems. But you want to go anyway. You prepare, you go out. It could be an adventure. It could be a disaster. Going to the moon and Mars is going to be like that too. You leave the familiar surroundings of Earth, you go out in space, potential problems, issues, equipment breakdown, many of the same kind of problems that you might have on a camping trip, the astronauts might face on Mars. It could be a challenge, it could also be a disaster.
A major hazard the crew will encounter will be prolonged weightlessness in the zero-gravity environment.
Easy, Georgie. Oh yes, it's true.
Relieved of bearing its usual load, the human skeleton starts to deteriorate. There's a loss of calcium phosphate, a chemical critical to the rigidity of bones, and the number of bone cells actually decreases.
For 24 hours a day, you're floating, and your body very smartly starts physiologically to adapt to that new circumstance. So in order to counter that, try to keep your strength up, I get on a treadmill. 2 1-hour periods a day, it's about all you can muster up there. In spite of that, came back at about 65% of my pre-flight strength level, a lot of muscle atrophy, and more significantly, about a 14% bone loss. Hips, lower spine. You get up in space, you're floating effortlessly, the bone just keeps dumping calcium. And that could be a showstopper on a long-duration flight.
It was only through intense physical training after his return to Earth that Lineker was able to reduce his bone loss from 14% to 2%. The debilitating effects of weightlessness remain an issue that must be addressed before we set foot on Mars, let alone colonize it. Research continues on a possible solution.
A lot of people have looked towards artificial gravity, which means you spin the spacecraft up and you end up with a gravity, and that would sort of help load your bones, because when you're in weightlessness, your fluids are shifting, your bones are unloaded, and you lose about 2% of your bone mass per month. It would be a large hurdle because in order for crews to be healthy when they arrive at Mars, they need to be strong for the entire trip.
Nobody's ever built a rotating spacecraft before, so nobody wants to be the first person. But most people believe that some kind of artificial gravity with a rotating spacecraft on the way to Mars is actually the way to do the mission.
Missions headed for Mars also face danger from solar storms. High-energy particle bursts unleashed from the sun could wipe out a crew if they aren't prepared for the onslaught.
So radiation is one of the largest showstoppers in terms of technology that needs to be developed for a future vehicle. The easiest way to deal with that is just make a storm shelter, so that if you can somehow predict when the solar storms are approaching, which you would do with various navigation satellites and relaying them from Earth, then you could get into the shelter and wait it out and then be able to go back into the spacecraft. And then similarly on Mars, when you know that there's a storm coming, you would go into a shelter.
The journey alone will make colonizing Mars an unprecedented challenge, but the enormous risks come with historic rewards. No decision is more important than who gets to go. Think you have what it takes to be a space pioneer? Get in line. There are people already training for the job. Colonizing Mars will require a special breed of people. With missions that could last more than 2 years, selecting those with the right stuff to be planetary pioneers will be critical to the success.
2, 1, we have ignition.
The cost of a launch, in the billions of dollars, and the tight quarters of the spacecraft will keep the number of crew people to a bare minimum.
I believe that number is 4. It's the smallest number you can send and divide the crew up into 2 groups and have no one be alone. And it's the smallest number that you can send in which you have the 2 primary skills of the mission both multiply backed up.
A crew of that size would consist of 2 ace mechanics who can fix anything, and in doing so, save lives. Joining them would be 2 field scientists, the intellectual payload.
So in Star Trek terminology, I want 2 Scotties and 2 Spocks.
Mars colonists will need more than just these vital skill sets. They also need to be mentally tough.
People think that astronauts are tough. They will just always obey commands and will operate according to plan. But they are human, and humans in these situations do develop strange psychological reactions. We really have to understand that, because that's part of the crew selection process.
All right, I'm going to fly into the node.
Astronauts will have to adapt to the confined space of the crew vehicle or habitat. If you're claustrophobic, forget it.
And we actually test for that. We put you in sort of a ball, zip it up, it's totally dark, you're crammed in the thing.
Inside the sleep cabin, there's also a little window. Sleeping bag sitting right here. This just happens to be the commander's sleep station.
And they have heart monitors on you. In my case, I fell asleep. They finally came, opened the thing up, said you're fine. But if you don't fall asleep in a closed space, you're not the right person.
Dealing with being the only life forms on an otherwise lifeless planet will be another major psychological challenge.
Out there in space, you truly are just removed from mankind. And, you know, the interactions we have in life with the colleagues, friends, family, you just sort of take them for granted down here. But up there, all of a sudden, it is isolation like I've never felt before. If you're not totally comfortable with yourself, you're going to have some very, very difficult times up there.
So it's been 4 months simulated Mars mission. Everyone's doing great.
To train people for this extreme mission, the Mars Society has built 2 Mars analog research stations to practice simulated missions. Crews consisting of as many as 6 people, mostly university scientists and NASA personnel, operate under many of the same constraints that astronauts will endure on Mars. They don't go outside without wearing spacesuits. They live on Martian time, 37 minutes longer than an Earth day. Their communication with Mission Control in Denver is on a 20-minute delay to simulate the time it takes for a radio signal to go from Mars to Earth. Maybe most challenging, they must coexist in a habitat with minimal personal space.
By doing that, you find out what works on Mars and what doesn't, and what kind of skill mix, what character mix you need in the crew, what technologies are likely to be most useful to the crew, how to organize the crew, who should command the crew, how tight you can ration the water and still sustain morale while you're doing this kind of work. This is not like a lunar mission which only lasts a week, where you can get 3 test pilots and they can just suck up the fact that they don't really like each other for that duration time and get along.
crews first go to the Desert Research Station, located outside Hanksville, Utah, to conduct short-term missions lasting 2 weeks. During that time, they perform EVAs, extravehicular activities, such as collecting soil samples for geological study. After completing their desert work, the crews are ready to join longer missions, lasting up to 4 months, at the research station on Devon Island in the Canadian Arctic.
Devon Island is one of the key places that you can conduct Mars research because of its isolation. It's the largest uninhabited island in the world. There are no signs of life around, maybe some bacteria and algae growing on the rocks. And also because the crater formation that the research station is located on is similar to a crater that you would typically find on any planet. There's a lot of permafrost up in the Arctic, and drilling into there looking for microbial life could be a similar experiment to what you would do on the surface of Mars.
We're going on our radiation/weather station EVA. We'll be taking readings of the surrounding area.
In addition to conducting field research, scientists at both stations also study each other as part of what they call human factors.
The human factors research looks at the interactions between humans and computers, the interactions between humans and their environment, and with each other. By learning how we're going to react with each other in different situations, we can then learn how a crew will react together on the way to Mars or on the surface of Mars.
A lot of our findings sound very obvious, but they have not really been paid attention to before. For example, the very first thing you learn is that this activity, a field exploration while wearing a spacesuit, is a physical activity. The amount of exploration is very much contingent upon your physical fitness. So what is this saying? It's saying you don't want to go to Mars in zero gravity if you want to actually get anything done, because you'd be deconditioned.
Another key finding was determining how little water humans need to survive. It's a drop in the bucket compared to the 125 gallons a day the average person uses.
We have found that with careful rationing and with the right kind of crew, we can limit water use down to about 3 gallons a day per person, taking sponge baths every other day instead of showers every day, and carefully rationing it. But if we try to cut the water down much below that, then it does in fact start interfering with morale in a serious way. And this is a very important number to know from the point of view of the engineer designing the mission and how much mass you need to ship.
The Mars Society shares data from its Arctic and desert research stations with NASA. The space agency will study the findings as it plans a future base on Mars, the next step to colonizing the planet.
See you soon. Space.
The year is 2040. The destination? Mars. After decades of careful study and research, the first human explorers are on their way to the Red Planet. After completing the 6-month journey from Earth, the longest manned space trip in history, it's time to land on Mars. But where's the best place to touch down?
You want areas that are geologically diverse, where there's a lot of different things to explore within a reasonably small radius of action. You want to definitely include areas that had water in them in the past, because that is where there could have been life on the surface. That's where you want to hunt for life. You want to go to places that are either in the temperate or tropical regions of the planet, because you don't want to go to a place where it's going to be dark for 12 months at a time.
By these criteria, the best place to land would be just north of the Valles Marineris, within driving range of runoff areas. Not far from where space probes Pathfinder and Viking 1 touched down. It's also the best place to establish a base camp that will function much like one in the wilderness on Earth.
Here in a remote wilderness area, we can establish a base camp because we have everything we need. We also rely on the environment. We get oxygen from the environment. We get water. We get wood for fire from the environment. Well, now let's imagine colonizing Mars. On Mars, we also rely on the environment. Colonizing Mars is going to require using the oxygen from the Mars atmosphere that we could derive from the carbon dioxide, growing food on Mars, getting water from the atmosphere on Mars. The same mix of resources from the environment and material that we've brought with us is what's required to allow us to successfully colonize space.
Once the base has been established, the primary objective of early missions is to search for evidence of life in the past and the present. Using radar, astronauts attempt to locate groundwater within a few hundred yards of the surface, then bring it up with drilling rigs. Samples will be studied under microscopes in the crew habitat to see if they contain evidence of life. If the planet proves capable of supporting life, then it would be viable for astronauts to construct greenhouses and cultivate crops using Martian water, soil, and sunlight. As they search for life, these pioneering astronauts will have to contend with the one force that could bring the lofty ambition to colonize Mars back down to Earth. That's gravity.
The gravity on Mars is 1/3 the gravity on Earth. We don't know if that's enough gravity to allow for healthy bones and muscles. If Mars gravity is not suitable for human long-term survival, then it may become the place we visit. We may go there for a week or so. It's a tourist attraction, but it's not a home. And so that's a fundamental question that needs to be answered. Is 1/3 gravity enough gravity for us to live biologically fit lives? My guess is the answer is yes, but we have no direct data, so we can only guess.
Discovery and Alpha, capture confirmed. And ISS is in...
Getting direct data will be vitally important.
Houston copy.
So will communicating it to Earth. The lag time in radio communication between the Mars crew and mission control, as much as 40 minutes depending on planetary alignments, will affect how the astronauts conduct their research.
It certainly means that the Mars crew is going to have to be a lot more autonomous than you could have with human crews in Earth orbit or on the Moon. You're not going to be talking to the Mars crew, okay, now step 2 steps to the left and head towards the rock. They are going to have to make their own decisions, and I think more generally the Mars mission is going to have to be led from the front, and that the commander of the Mars mission will be in the Mars mission, and rather than have mission control, we will have mission support on Earth.
Good luck. Back to work now. Back to work, all you guys.
The habitat that will house the astronauts offers a preview of structures that could form the first settlement on Mars. As proposed in the Mars Society's direct plan, the initial habitat will be the crew vehicle itself. The tuna can, as its proponents call it, is about 20 feet tall and 27 feet in diameter. It has 2 decks, the upper level for cabins and a common area, the lower one for lab and workspace.
We have found in our field work that while these are tighter quarters than most Americans are used to living in, they're not that bad. You don't really feel that crowded. We tend to keep the private bunks very small so that we can maximize the public space, the wardroom where people hang out. If you've got a healthy crew where the people want to associate with each other, then this is clearly the best way to ration the available space.
As more pioneers settle on Mars, it may be safer to move the growing community underground.
Because it's a terribly dangerous place. There are sandstorms that can hit and knock over any surface establishment. There's horrible ultraviolet cosmic rays effects. You're going to want to save people's lives, save their reproductive abilities. You're going to want to have a place where you can raise children. You're not going to do that at the Martian surface. You're going to be doing that underground. Under those circumstances, it would be more like vast urban malls, probably very nicely lit, nuclear and solar power. It shouldn't be a terrible life, providing that they get to a tipping point in technology, a tipping point in support from the outside world.
Early missions to Mars, if conducted during optimal planetary alignment, will last approximately 2.5 years. That includes the 6 months to get there, a 1.5 year stay on the surface, and the 6-month return trip to Earth. During that time, we will know whether Mars can support life. If it can, that opens the door to the ultimate form of colonization. Terraforming the planet to make it more like the Earth. Once humans establish a self-sufficient base on Mars, the next major advance in space colonization, say advocates, will be to terraform the planet, a process that will make Mars Earth-like. Wherever humans have settled, they've remade the environment to suit their needs. Mars may not be any different.
Terraforming is perhaps the ultimate way to create a new Garden of Eden in outer space. And how would we do it? Take a look at Mars. Mars is a frozen desert. First, we would have to raise the temperature.
We know how to warm up planets. We're doing it right here on Earth, where it's not a good thing. Whereas on Mars, it would be a good thing. So in fact, we could do the same things we're doing on Earth, putting in the atmosphere greenhouse gases, which would cause the planet to warm. On Earth, that would be pollution. On Mars, it's medicine.
Calculations have shown that the amount of greenhouse gases that we need to introduce to Mars are reasonable. They're not really way beyond what we can imagine to produce. But the amount is also too large for us to bring it from the Earth to Mars. That means that those gases have to be produced on Mars. We would need to set up factories to produce those gases and release them into the environment.
These factories would combine elements taken from the Martian environment, convert them to non-toxic fluorocarbon gases, and vent them into the atmosphere. Experts estimate in about 100 years, these greenhouse gases will have terraformed a cold, dry, dead planet into a warm, wet, life-supporting world.
It's interesting to think about what would Mars look like after 100 years of warming. It would be bluer than it is today. You'd see large patches of water. You start seeing little fringes of green around the margins of these blue areas. And then with time, this infestation of green would move away and up and into the mountains. And eventually, you'd see a world of blue and green with little islands of red that remain, almost like national parks preserved.
Even in the first stages of terraforming, the temperature will rise and also the atmospheric pressure will rise. That will mean that humans will actually be able to go out just in suits that really press down on their skin in order to recreate some pressure and with an air mask. And that would really make it much easier to go outside. It would probably take quite a while for Mars to become really a place like this, where we're in a greenhouse at the Los Angeles Arboretum. It would definitely take a while before we have such a paradise as this. But we can start from very basic algae, mosses, maybe grasses.
While this is going on, genetic engineering of the people themselves could also be taking place, so that you are breeding in, either through selection of your offspring or possibly even genetic manipulation, generations of citizens who need less gear when they go out on the Martian surface. Their skin is less fragile to the ultraviolet, to the low-density atmosphere. And eventually, they just need their respirators less and less. As the atmosphere increases, so does their ability to meet the atmosphere halfway. And these would be the beginnings of the true Martians, the people who could actually make this world their own.
NASA itself is not interested in terraforming planets, partly because it sounds very science fiction-y, but partly because there are real ethical questions involved. You will find a lot of people who believe that human beings should not go into space because we will just destroy things in the way that we've destroyed our own planet, and that we need to preserve the Moon and Mars and the other planets the way they are for scientific investigation.
Whether we should terraform Mars is an issue for future generations to resolve. It's a very distant point on a space colonization timeline that could begin with this generation. Jupiter is 500 million miles from the Sun, a giant sphere of intrigue. This churning ball of gas may look like an artist's rendering, but it's the real thing.
Jupiter has the most exotic weather patterns we've ever seen in the solar system.
Jupiter is 84% hydrogen and almost 14% helium, the two lightest and most abundant elements in the universe, rolled into a mammoth mass.
This thing is 11 times the diameter of Earth, and you could take 1,000 Earths and stuff them inside Jupiter comfortably.
Jupiter really is the lord of the solar system. You know, about 70% of the mass in all the planets is in Jupiter. If you're talking about planets, Jupiter is the big boy in the block, and it really does rule the roost.
Jupiter is the largest planet in the solar system, visible to the naked eye. A day is only 9.9 hours long, and it takes 11.86 years to orbit the Sun. A 150-pound person would weigh 350 pounds on Jupiter. There are thunderclouds made of ammonia, sulfur, and water. Exploring Jupiter would be NASA's most daring mission to date. It's a hostile place with temperature extremes from frigid to fiery. Its electromagnetic radiation is intense. It could kill a traveler to the planet in an instant.
We would need heavy lead protection, and that's very difficult to lift off the ground. So we have some difficult engineering challenges to actually bring human beings to the planet Jupiter.
A landing on Jupiter is not going to happen. Jupiter itself is a very gassy planet. It's made of gas, so you would not have a solid surface on which to land and walk around. You would just keep descending through the clouds and then be eventually crushed by the pressure of Jupiter's atmosphere that make a human trip to Jupiter quite a challenge.
But what if we could go there? Dr. Andrew Ingersoll is an authority on the planet. He takes us for a ride.
You need a special kind of balloon because Jupiter's atmosphere is hydrogen. Hydrogen is the lightest gas. A helium balloon would sink. So the only thing that'll float in a cold hydrogen atmosphere is hot hydrogen. And so you need a hot air hydrogen balloon.
For the past 10 years, NASA has been developing ultra-long duration balloons for robotic exploration. And as we all know, heating hydrogen is a tricky thing. But just how this behemoth was born is a puzzle.
The formation of Jupiter is the greatest mystery associated with the planet.
Some believe Jupiter may have been a failed star. Like the Sun, it had the right ingredients, hydrogen and helium, but not enough mass to create the internal pressure and temperature necessary to have nuclear fusion. So it became a planet instead.
The thought is that there was this cloud in the galaxy that had the same composition as the Sun. And it collapsed under its own gravity, and some stuff was left behind, and that stuff became the planets. And the majority of that stuff became Jupiter, and the rest of it course, went into the sun, and then there were a couple of little tiny leftovers like Earth.
Jupiter's spinning gases attracted like elements and over time grew bigger and bigger in the process. Almost like an oyster creating layers around a grain of sand to make a pearl. What gases and solids Jupiter didn't ingest, it spat out into space.
So Jupiter is like your big brother in the schoolyard, protecting you from bullies that might wreak havoc on your existence.
I tend to think of it as more of the cosmic frisbee guy. It's grabbing things out of space and it's also tossing them back out. It ends up keeping those objects from the inner solar system where Earth and Mars and Venus are.
By cleaning some of the debris up, kicking some of it out, shooting some of it into the sun, where it'd be lost forever, Jupiter cleaned out a path that the other planets could exist in some sort of peace.
So dominant is this frisbee phenomenon, Earth may owe its very existence to Jupiter.
It influences the courses of comets and even some meteors and asteroids, so that over the eons, the fact that Jupiter is there helps dictate what happens in the inner solar system. So really, the presence of Jupiter may be one reason why we have life on Earth and habitability and be able to have the Earth a nice environment instead of getting pummeled by so many comets.
There is no greater proof of Jupiter's power play than what happened during a 7-day period in July of 1994. A comet called Shoemaker-Levy 9 barreled toward Jupiter. Once under Jupiter's influence, there was no going back. A missile was on a crash course with a ball of gas. Jupiter's gravitational pull was so great that it broke the comet into small pieces that came in one at a time. These pieces assaulted the planet at a speed of 37 miles per second.
When you have a missile going at supersonic speeds, you get a shock. You can see sort of clouds of material being jetted up from beneath where it landed.
One of the fireballs generated by the collision with Jupiter's atmosphere flared 1,800 miles into space. Had Earth been in the projectile's sights, the effects of such a smash-up would have been catastrophic, to say the least. Similar to the event that wiped out the dinosaurs.
The energies that were released in those fragments hitting was larger than, on the order of 10 or 20 times more powerful than the entire world arsenal of bombs.
Take Jupiter out of the picture, bring this giant comet into the inner solar system. Where would it have gone? We have no idea. Might have crashed into Earth. If that comet had crashed into Earth, things would be a lot different around here.
The experts believe that comet strikes on Jupiter may be 8,000 times more frequent than those on Earth, thanks to the Frisbee effect.
But it cuts both ways because Jupiter has no value system. When it sees an errant comet, it may attract it and swallow it up, but where it flings it is anyone's guess. And so errant comets can be flung in towards Earth, they can be flung into the sun, and they can be flung out of the solar system.
There's a reason the planet rejects some of the space junk heading its way.
Jupiter, being the biggest object in the solar system, has the most gravity. And so other objects, little fleas that have their own trajectory flying by, are bent from where it would be towards Jupiter, and usually with an acceleration. And that acceleration can cause it sometimes to just be ejected completely.
No earthly frisbee thrower can match Jupiter's flinging force. It is much faster than any bullet ever known. It rejects things at a rate of 30 miles per second. Jupiter's wonders are hard to fathom. They've captivated man for centuries.
Prehistoric humans realized that it was moving among the stars, and it was one of the planets that they appreciated. And Jupiter was the king of the gods, after all, in Roman mythology.
And there may be a biblical reference to Jupiter.
Ever since I was like 5 years old, I remember people, oh, that was the Star of Bethlehem. And whether or not it really was, obviously we have no way of knowing. But it's not clear whether the star that was talked about is a single star or whether they meant an astronomical alignment of objects in the sky. We don't really know.
It's known as conjunction in scientific terms. According to researchers, Jupiter and Venus did appear as one large star-like object in August 3 BC and would have been visible in the eastern night sky. But it was Galileo, the father of modern astronomy, who made the first recorded sighting of the Jupiter system.
In the early days of 1610, only about 18 months after the telescope was invented, he got his own telescope and he looked at Jupiter.
In 1665, Jupiter's most fascinating feature was discovered. Its giant red eye was actually the eye of an enormous storm, unlike any experienced on Earth. This one has raged for at least 300 years. This weather disturbance is a meteorologist's dream.
Jupiter's Great Red Spot is truly huge. You could take Earth and fillet it out and it wouldn't even really cover the spot.
This storm is the hugest storm in the solar system. Just to give you a feeling about it, it's about 12,000 miles. And the Earth is only 8,000 miles wide.
And the winds blow quite fast around the edge, but it's calm in the center. It's not like a hurricane, which has an eye and very fast, turbulent winds in the center. The red spot is rather calm. If you were in a balloon, it might be a pleasant ride, as long as you avoided the small-scale stuff like the thunderstorms and the turbulent places. Even though you'd be going very fast, it might be quite calm.
Fast as in 350 miles an hour. The fastest wind ever recorded here on Earth was 231 miles an hour. But is it an Earth-like storm?
It's a giant collection of clouds roiling around, lightning going on. So we can only model and imagine what kind of precipitation, but condensation in the form of condensed vapor of various gases.
This famous red spot is a high-pressure system that can take 10 days to complete a rotation.
It's really a backwards hurricane. It's called an anticyclone. That's the name for it. So it goes backwards from the direction of a typical hurricane.
That's not the only curious thing. Hurricanes as we know them need water in order to form. There's no water engine in the red spot. This never-ending weather system is feeding on something else. But what? Jupiter's Great Red Spot is something like a non-stop hurricane. It's a colossal storm, complete with violent wind and lightning. Storm chasers would love to go running after it. Dr. Tim Dowling of the University of Louisville is in the hunt for similar phenomena here on Earth.
The red spot is, think of it as a huge extra lens or egg shape of mass. It's just an enormous thing. It sort of quiets down the fluid, it presses it down into the hotter interior so you don't get thunderstorms. But if you go on the edge of the red spot, especially northwest, you get some of the most horrific thunderstorms you're going to find on the Jupiter.
The spot doesn't have an eye, and it isn't fueled by water. There's no ocean over which it forms. What then keeps it going and going?
I've always likened it, in my own view, as like a mini volcano inside of Jupiter.
Actually, an atmospheric volcano. Dr. Baines believes that warmer gases rise from heat deep within the planet. While trying to escape, they create a vortex.
So, for some reason, I believe there's extra energy right there.
But it's just a theory. Science is left without answers to that question and others. Current theories cannot quite explain why the spot is so well formed and why it stays in one place. The plot thickened over the years as scientists learned even more.
It became a deeper mystery because instead of everything just sort of smoothly going around the red spot, we saw this turbulence, and there were smaller scale structures that would come and go every day, and it was chaotic and turbulent, and yet the red spot just existed and sailed on.
Jupiter's storms aren't limited to the Great Red Spot. Cloud decks 3 layers thick hover and cover the planet.
If you were inside the atmosphere of Jupiter, you would hear very loud thunder. In fact, the thunder actually travels 4 times faster on Jupiter than it does on Earth. It's about 3,000 miles an hour. The rain falls twice as fast on Jupiter. The charge separation that pulls the positive charge to the top of the clouds, the negative charge to the bottom of the clouds, is twice as efficient on Jupiter for that reason alone, because the rain is falling so much faster. Towers of cumulus convection that you see on Jupiter are 3 times taller. They go up 30 miles, whereas on Earth they go up 6 or 7 miles.
It would be impossible to survive within the Great Red Spot with its 350-mile-an-hour winds. By comparison, Hurricane Wilma, which had the highest recorded winds of any earthly storm, slammed into the Yucatan Peninsula in 2005 with barely a breath. 175-mile-an-hour blasts. Our weather is simple. Jupiter's is complex.
Now on Jupiter, you just basically have one storm system sort of stacked on another, with lots and lots of room. Basically, these are the storms in their natural state.
These storms move relentlessly within Jupiter's other distinct feature, streams of fierce jets that continually circle the planet. Scientists are only beginning to understand what they are and where they come from.
There's a massive eastward flow of material, and that means material's flowing more than 1.5 football fields per second. That's really moving. You don't want to be in that.
29 other belts and zones of varying widths extend outward from there. They are what give Jupiter its characteristic appearance. They move in alternating directions, some eastward, some westward.
They're much smaller scale, the high latitude jets, than the equatorial one. As far as in comparison to Earth, these are massive, super fast, high speed winds, and yet they're just going back and forth.
The planet's rotation rate has something to do with it. Jupiter generates a lot of energy because it really moves.
So the very nature of the spinning causes Jupiter to not just have one jet stream, but many jet streams going in opposite directions along the planet. And so you can see these zones. So what you have is an exaggerated version of Earth's basic weather pattern.
The spectacular swirls are created in surface clouds where the zones meet. It's believed that the energy ultimately powering this belt phenomenon comes from intense heat deep within. It's not unlike something we see every day.
Boil a pot of water on the stove, it'll start bubbling, and bubbles come up from the bottom and try to get out, trying to circulate that water, that currents around. So it's the same thing inside Jupiter. We have gases and liquids down there that are trying to get the heat out.
There are basic questions, basic pieces of physics to go after, to explain. Massive jets. Shouldn't we be able to explain that?
Earth has just one primary jet stream. It moves eastward, and another major flow that blows westward, the trade winds. Triple that power, and you've got the jet streams of Jupiter.
Totally different from Earth. And yet, I should be careful, not totally different from Earth, just Earth on steroids.
And you ask yourself, wow, if I understood what's going on Jupiter, Earth would be just a piece of cake.
Jupiter's mysteries aren't limited to the planet itself. Some of its most intriguing elements are circling around it.
Jupiter's got several dozen moons that are big enough to be seen. It's probably got a lot more that are too small to be seen with current technology, and no doubt in coming years more will be discovered.
Some of the moons are almost the size of some planets. So really Jupiter is its own little solar system.
Thanks to its incredible gravitational pull, it sucked in asteroids along with other space debris. For the most part, there is order, but there are some erratic moons in orbit around Jupiter. It's managed chaos.
You can imagine a bunch of runners in a track in their lanes that each runner stays in. They won't collide. That's kind of how celestial mechanics.
Each moon holds its own fascination. 4 of Jupiter's prominent moons were discovered by Galileo. He first observed that they revolved around the planet. They are named for Jupiter, the god's lovers.
The first major moon you come to is Io, which is this very active place with lots of volcanoes. It's almost all the time going off.
Shooting out magma 200 miles into space. Io is a wonder, pockmarked with over 100 volcanoes, some the size of California, which seem to turn themselves on and off. Ganymede is the largest moon in our solar system, 5 times the size of Earth's moon. Callisto is the most heavily cratered. It has clearly taken a beating in its lifetime. Then there's Europa, the ice queen to Jupiter's king. No one knows its makeup for sure.
It looks like a cracked egg. It really looks like the whole thing had liquid water on it at some time. It froze and it cracked. And we believe that these patterns are due to tidal forces that crack it.
As alien as Europa seems, it is smooth and glassy in some spots, hilly in others. In fact, it is remarkably similar to one of Earth's frozen wonderlands.
There is a lake in Antarctica called Lake Vostok that scientists think is an analogy to what we see in Europa. Antarctica has a huge thick ice crust, and underneath there is this liquid lake, and we think that this may be very similar to the water ice underneath the surface that we see on Europa.
You go down through that crust, go through the ice enough, you'll get liquid water. And we are very convinced that there's liquid water down there. It's the only place that we know of besides the Earth which has liquid water in large bodies that have been there, we believe, for more than 1 million or 2 million years.
And where there's water, could there be life? Jupiter's moon Europa is bursting with secrets. It may even have warm thermal vents deep below its frozen crust.
In fact, an immense ocean, bigger than the Pacific Ocean, worth of liquid water down there that's just sitting there for things to happen to.
The presence of water means one thing. We may not be alone.
I want to go ice fishing on Europa. Cut a hole, put a submersible, look around, see if anything swims up to the camera lens and licks the camera. That's what I want to do.
One scientist is planning just such a fishing trip. At this outdoor lab near Austin, Texas, hopes are hanging on a little robot.
This is designed for exploration in unknown territory, completely unknown territory, and the search for biological life.
It's a deep phreatic thermal explorer, or Depth-X for short. Its proving ground right now is a local quarry. And there are big plans for its future.
If everything went according to plan, you would launch around 2016. It would be at Europa by 2018, and by 2019, for certain, we know whether there's life off Earth. That's the game.
Depth-X is the brainchild of engineer Bill Stone. He and a team of scientists have staked their reputations on it. They've spent 6 years developing the concept and building the prototype. It's part of an ambitious project that would see it carried into space, sent through 6 miles of ice, and into Europa's ocean.
To divide it down into all the various vehicles, you have a parent vehicle which takes you to orbit around the moon Europa. There will be a lander. It'll land on the ice. Then there's a second stage of the lander which melts its way through 3 to 5 kilometers of ice cap, and then at that point you kick out the third stage. We need a fast-moving device that would be sort of torpedo-shaped, most likely nuclear-propelled, and that would drive for thousands of kilometers around the central ocean of Europa.
Is that really feasible? NASA thinks so. The space agency is on board with money and its blessing, an investment in the search for life. If life exists on Jupiter's moon Europa, could it walk, talk, or fly?
It would be little viruses or, maybe at best bacteria. We would expect only to see primitive life forms, but they might be similar to things that we see on the Earth. We just don't know.
Scientists are encouraged by the discovery of strange and hardy life forms found in the most inhospitable places on Earth. Tube worms, for example, survive and thrive in total darkness. Extreme pressure isn't a problem. The creatures were discovered in 1977, several miles below the surface of the Galapagos Rift. They exist in water near superheated thermal vents. It's believed that these very conditions, darkness, high pressure, and hydrothermal vents, are present on Europa.
You could have hydrothermal vents kicking up warmth and nutrients down near the core of Europa, and that organisms would have fed off of that material just like they might have in the early Earth.
And while tube worms might not be lurking beneath Europa's icy shell, something else could be.
Its microbial life is the bulk of life on Earth. We expect that branches of that type of life will exist on Europa, just simply because water is the key feature.
Finding it consumes scientist Bill Stone. His DepthX may answer a question that excites seekers of knowledge.
Can we have the robot behavior look for signs of life and then try to collect a sample based on what it's sensing?
Stone's baby is in its infancy. At the same time, it is futuristic and advanced. It's a high-tech toy like no other that might show our world what another is all about. Our first contact with extraterrestrial life may be on Jupiter's moon, Europa. The DepthX robot, or more accurately, Hydrobot, is being designed to ultimately think, move, and explore without help from man.
And that is all to be done by the robot itself. We're not going to be guiding it to do that. That's going to be a big step forward in what we would call robot science autonomy.
It's a real-life HAL, the star of a new space odyssey.
Where it's literally hit a button and let it dive below the surface, and we won't see it again until it tells us what's down there.
DepthX will be able to extract and analyze samples on its own as it navigates the ocean.
This little tube you see down here will pull in water samples and store them in 1-liter bags. We have 5 of them on board. But before it does that, it actually powers through a series of micro pumps over here on the left and brings it into an onboard microscope. And that microscope will take images of what's in the water down to about 5 microns. So we can see most of the typical types of microbial life from 5 to 200 microns on screen. The robot will use that to discriminate to determine if there's life and then grab a sample.
DepthX and its systems must be made smaller to work in space. And it still must pass trials under ice flows.
We are testing this in Antarctica to make sure it all works totally under ice.
The question of life on Europa is probably the big unknown, because that would change our whole view of the universe, basically. I mean, if this little moon sitting out there in this hostile environment of Jupiter can have life form on it, that means that probably tells us that life is almost everywhere.
The science is there. I mean, I think searching for life is one of the most compelling things that we can do as not only as scientists, but as a race, as human beings.
It's a giant leap, and not just for mankind.
No, for robot kind.
Of all Jupiter's imposing features, none is more impressive than the one you cannot see. It's bigger by far than the Great Red Spot, more dynamic than the bands of jet streams, and as lethal as any killer known to man.
You have one of the most powerful radiation environments in the solar system, aside from the sun.
The magnetic field of Jupiter is the largest entity, I believe, in the solar system.
It is a bubble 450 million miles long, buzzing with electrically charged particles. It's Jupiter's magnetosphere.
The sun's sitting here putting out the solar wind, and the solar wind is charged particles of protons and electrons.
These particles flow along at 1 million miles an hour.
And Jupiter basically captures these protons, electrons, all these charged particles like electrical currents, and it has it then in space circling around Jupiter.
No word in the English language accurately conveys the enormity of this phenomenon.
The magnetosphere of Jupiter is the biggest object in the solar system. It's a lot bigger than the sun.
comparisons are the best measure of this mega mighty wonder.
If it were visible in the night sky, it would be many, many times bigger than the moon. It's enormous, even though it's 5 times as far away from Earth as the sun is, it still would look immense in the night sky.
If visible, it would take a familiar form, a windsock. There's a rounded section facing away from the planet in one direction, with a tail flowing out the other. This windsock reaches the outer orbit of Saturn. Power plant Jupiter generates up to 10 million amps of electrical current.
The biggest planet in the solar system can conduct electricity all the way through it and around it.
This conductivity creates a phenomenon we can see when the excited charged particles escape.
Jupiter has auroras because when those particles leak in and crash into the upper atmosphere, it glows, and just as Earth has auroras.
These ghostly auroras are 1,000 times more powerful than Earth's northern and southern lights. They measure up to 1,200 miles across. If you could stand under them, they'd fill the entire sky, moving at lightning speed, 10,000 miles an hour. Jupiter's magnetic field is a monster, and it roars. In fact, it's speaking to us right now. Jupiter, the giant of the solar system, has something to say if you're listening.
We can hear what we call lion roars because it has this roaring sound. We can hear whistler modes. We can hear hiss and whistles that are going pew, pew, pew. And these are all indications of dynamics, things that are happening in the magnetosphere now.
If you find yourself driving on a dark desert highway, your AM radio might just tune in to the strange sounds of Jupiter's magnetosphere. The bursts are as short as a few seconds and as long as a couple of minutes. They come and go every hour or two.
Most of it sounds like static, but every once in a while you pick up something that sounds like a rising tone or a falling tone.
Some listeners have described audio spasms that sound like woodpeckers or waves crashing on the beach. The noise is disturbing. But just why the planet was talking remained a mystery until Voyager 2 passed through the outer magnetosphere in 1979.
Nobody really understood for a long time how those signals were generated. So that was one of the things that was on my mind when I got interested in Jupiter. What in the world was going on with these radio emissions?
It is one of the few secrets finally surrendered by Jupiter.
And that answered some questions, but it raised new ones. And I think that's the way it should be. If you don't have questions, it gets kind of boring and dull. So I think that the fact that the planets don't give up their secrets easily, or the universe doesn't, that's part of the game. It's what makes it interesting.
Jupiter keeps astounding and confounding scientists. One surprise came in 1979 when it was discovered that Jupiter has a ring. It's nothing on the order of Saturn's. Still, it's another feature that fascinates.
All of the giant planets have rings, probably left over from when the planets formed. And the moons coagulated out of the gas that was there, and then it could be a failed moon. So Jupiter's ring comes from material being knocked off of one of the interior moons. So it's dust that's collected from material that's coming in from outside moons.
The ring is slowly growing as new material flows into it. And there's a whole other side to the planet that remains a mystery. Why do these storm spots keep forming? There's the dark spot, for example. Glimpses of it were first spied in 1997. It appeared to be a huge, ominous cloud, twice the size of Earth, hovering above Jupiter's North Pole. There's a host of other spots, too.
There are other sort of smaller cousins that have come and gone. There were 3 ovals about half or a third the size of the red spot. And they sort of occupied the same latitude band in the southern hemisphere. And they'd been around since the 1930s. And amateur astronomers saw them form. And they were around till the late 90s. And 2 of them merged with each other. And then the remaining 2 merged, and now there's 1.
And it keeps transforming.
It turned red about 6 months ago, and now we're calling it the little red spot because it turned color. Now, why did it turn color is a big question. So there's chemistry going on, or some type of extra dynamics that's going on that just kicked in, and we need to start studying that.
Jupiter is a hostile and restless planet. Its giant gaseous body and violent storms make it one of the most alien environments in the solar system. Even though it is 500 million miles from us, we may have more in common with our cousin planet than we think.
I think the lesson to learn from Jupiter here is whatever's going on in our climate and our weather patterns here on Earth, Jupiter has more of it. But Earth is not an island. And there are better examples of what's going on Earth than even Earth itself.
For scientists, Jupiter is the king of many questions concerning our solar system and could possibly hold the answers.